Okay, now we're going to talk about probability that is either independent or dependent, independent or independent events. So we'll give some examples. So you have a coin, right? You've got heads or you have tails, right? So you take the coin, so I'll just put heads, comma, or slash tails. You flip a coin. The first time you flip, it lands on heads. And then you flip again. So you take that same coin, you flip again, and it lands on tails. Well, because those are two separate things, and flipping a coin has no bearing on flipping a coin a second time, these would be considered independent events. One flipping of the coin does not impact the other flipping of a coin. So these would be called independent events. There are 5 nickels, so let's go over here. There are 5 nickels and 7 dimes in your pocket. Okay, so 5 nickels. So nickel, 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 and 7 dimes. So dimes are smaller. Dimes, dimes, dimes. 4, 5, 6, 7. And those are all dimes. Okay, 3 times you randomly pick a coin out of your pocket, and then this is the key phrase. Each time you return the coin to your pocket, then you mix up the change in your pocket. All 3 times the coin is nickel. All right, so the first time, so we pick a coin, pull a coin out of our pocket, we get a nickel. But we put the nickel back. So there's a very good likelihood you still have the same number of nickels. So when you pick a coin out of your pocket, now maybe this time we get this nickel, but we also put that coin back. So that coin is still in your pocket again. So pulling out a nickel each time had no bearing, because once you pulled the coin out, but then put the coin back, it was still there for the next time. So these would also be an example of independent events. So this example right here, because of this phrase, you return the coins. This would be an example of independent events. All right. So here's an example. Your sock drawer has 6 white socks, 2 brown socks, and 6 black socks. Okay, so 6 white, 2 brown, and 6 black, right? You randomly pick a sock and put it on your left foot. So we started off with a total of 6 plus 2 is 8 plus 6 of 14 socks. Now, what does this say? You randomly pick a sock and put it on your left foot. So now we have 13 socks. We don't have the same amount. So after we pick our first sock and we wear it on our left foot, well, the second time we have fewer socks to choose from. So look at making this one selection and only leaving 13 changes the number, it changes the possibility for the second one that we random. So this is an example of dependent. because we did not return the sock before we picked another one. So that's an example of dependent. So let's come down here. Now we're going to actually find probabilities. A bag consists of 4 red marbles. So, all right. And 4 blue marbles. So let me go ahead and change this to a blue color. All right, we're going to pretend those are solid. You randomly pick a marble. So let's say you have these in a bag and the bag is not see-through. So those marbles, are in a bag and that bag is not see-through. So, you randomly pick one. You close your eyes, you pick a marble. You randomly pick a marble. So let's say we picked a red, but then we returned it. So all the marbles are still there when you go to pick another marble. So the first marble is red and the second. So this probability, so there is a total in the bag, there's a total of 8. But 4 of them are red. So if you pull out, you randomly pick a marble, then return it to the bag before picking another marble. The first marble is red. So the probability of picking a red marble is you have 4 possible options of picking out of the 8. All right? Well, that's a 1 to 2. If you simplify that, that's a 1 to 2 ratio. All right? Then you also have a 4 out of 8. This is red. This is blue. So this is one of the only times in mathematics when you see the word and, instead of adding, that's going to indicate you're going to multiply. So in this scenario, you have a 1/4 of an option of first picking a red marble, then picking a blue marble. So we did the probability of finding a red. We did the probability of finding a blue since you returned it. And so they have the same number with each pull. And because the word is and in probability, we're going to multiply those. Okay, so let's come down here. A basket contains 4 apples and 6 peaches. So 4 apples, 6 peaches, that's a total of 10 items. 3 times you randomly select a piece of fruit, return it to the basket, then mix it 3 times. Okay, this is a return again, and there's going to be 3 events. The first time you get an apple, so the probability of picking an apple is 4 out of 10. So that reduces to 2/5. And then, so that's the first event. The second time you draw all of the fruit, we put all the fruit back. The first time you get an apple. The second and third times you get peaches. Well, the probability of picking a peach is 6 out of 10. So that's 3/5. And then 6 out of 10 again, because this is the second time you draw, this is the third time you draw. So and because of the word and, we're going to go ahead and multiply. 2 times 3 is 6. 6 times 3 is 18. 5 times 5 times 5. So an 8 is a number between 0 and 1. So we want to convert 18 1/25 or even the 1/4 that we had up above. So I apologize for this, just a second. Okay, so that is going to be a 0.144 probability of picking one apple and then one peach and then one peach when you draw fruit from the basket and it's done in that order. That's the probability. All right, that's it for this one.